Hi learners, welcome again to this lesson. This is lesson 4. We are still looking at the topic water and hydrogen. In the previous lessons, we have looked at the preparation of hydrogen, collection of hydrogen. We also looked at the chemical properties of hydrogen gas in the previous lessons. Also, we have looked at how we can produce water or how we can prepare water, and also the products formed when we burn a candle in the laboratory. So in our lesson for today, we are going to look at the reactions of water with metals. So how do metals react with either cold water or water vapor, that is steam? So we say that some metals react with water while others do not react with water. The reaction between metals and water depends on the reactivity series. The higher the metals in the reactivity series, the more reactive the metal is with water. So we are going to look at several reactions of metals with water. So here we are going to start with the reaction between sodium and water. So we are going to prepare an experiment. Here we have the procedure, and later we are going to see what we are expecting to observe from our experiment. So we are going to put like 500 centimeters cube of water in a beaker. Then we can add some indicators. We can use phenolphthalein indicator, we can use litmus solution, we can use universal indicator, methyl orange. All these are indicators. We can choose one, and we are going to observe the change. Then the indicator is to show us whether the solution that is formed when we react a metal with water, whether it is acidic or a basic solution. So we are going to cut a very small piece of sodium. Remember, sodium is very reactive. So we are going to cut a very small piece, the size of rice. Then we are going to use a pair of forceps to hold the metal. We don't hold the sodium metal with our hands. It might cause harm because it is reactive. It might react with some water vapor in our hands. So we use a pair of forceps to hold sodium. Then we put it on top of the water that is in our beaker. So what are we expecting to see? These are our observations. So sodium melts to a silvery ball that floats and darts on the surface of water. It continues to decrease in size as the reaction continue to take place. So why does this sodium float on water? This is because sodium is less dense than water, so it will float on water, it will not sink. Then it is very reactive, so the reaction will make the piece of sodium metal to dart on the surface of water. There will be bubbles, or effervescence will be, we are going to see bubbles. This will mean that there's production of a gas. Always know that when we see bubbles, it means that there's production of a gas. So what will happen to our indicators? So if we decided to use phenolphthalein indicator, the color of phenolphthalein will turn to pink. It turns to pink. Then the color of litmus paper will turn to blue. Color of methyl orange solution will turn to orange, and the color of universal indicator will turn to blue. So all these observations in our indicators will prove that the solution that is being formed is a basic solution. So basic solution will turn our indicators to these stated colors here. So let us see what will how the experiment will look like. So this is our sodium. Remember, sodium and potassium are both reactive metals. They are high in the reactivity series, so their reaction is almost the same. So even for potassium, will behave the same way like sodium, but those potassium is more reactive than sodium. So this is the reaction here that will take place when sodium is reacting with water. So you can see sodium metal darting on top of water, and we are also going to see bubbles being produced there. Now, if we want to collect hydrogen gas, because when sodium is reacting with water, a basic solution of sodium hydroxide will be formed, and also a gas, that is hydrogen gas, will be produced. So this is the reaction between sodium and water to form sodium hydroxide and hydrogen gas. So if we want to collect our hydrogen gas, we are going to force the sodium metal to go below. We can use a funnel that will move the sodium metal down to the beaker containing water, and then we are going to cover it with a gas jar or a test tube. Then we are going now to collect our gas in our gas jar. You can see in that experiment here. So when sodium is at the bottom here, it will produce hydrogen gas. Then we can collect it on the upper side because hydrogen gas is slightly soluble in water. So we are going to collect our hydrogen gas up there. So sodium, we have said, is less dense than water. It floats on water and vigorously reacts to form an alkaline solution of sodium hydroxide and producing hydrogen gas. Sodium is thus stored in paraffin to prevent contact with water. So that is a very testable question in the exam. We can be asked why sodium is stored under paraffin. This is to avoid or to prevent its contact with water that will lead to the formation of sodium hydroxide. Okay, we move to the next slide. We say that potassium is very, very reactive, more than sodium itself. Therefore, its contact with water will explode. Therefore, we avoid using potassium for the reaction in the laboratory because it might be very explosive. So instead, we use sodium. So potassium also reacts with water to form potassium hydroxide and hydrogen gas, and that is the reaction. The other metal we are going to look at is calcium. So calcium is more dense than water. So when we place a piece of calcium in water, it will sink. So when calcium is added, it sinks and reacts moderately with water, producing a steady stream of bubbles or effervescence of a colorless gas. So also calcium metal reacts with water, though not as vigorous as sodium or potassium. It reacts moderately, but it also produces hydrogen gas and also produces a weak base of calcium hydroxide. So this is the reaction here between calcium and water to produce calcium hydroxide and hydrogen gas. Then we look at the other metal, that is magnesium. So how does magnesium react with water? So when magnesium reacts with cold water, it also produces hydrogen gas, but for this case it will not produce hydroxide, so it will produce magnesium oxide and hydrogen gas. This reaction is slow. Using cold water, the reaction between magnesium and cold water is too slow. So for that reason, we react magnesium with steam, that is water vapor, to make the reaction more fast. So let us look at an experiment that shows reaction of magnesium with steam. So we are going to arrange our apparatus like this here in this experiment or in this setup. So here we have wet sand, or we can have cotton wool or glass wool soaked in water. So most times in the lab we use wet sand, then we heat it. Remember, we first heat this wet sand. You can see here it is to drive out air. So it will produce steam that will first drive out air in this apparatus. Then here we have our magnesium ribbon. Then we are going to heat it also. Then this is the boiling tube or the ignition tube. Then now whatever gas will be produced will be moving down to this delivery tube and then to this gas jar. Remember, this magnesium will be reacting with the steam that is produced by the wet sand, then producing a gas that is hydrogen gas. So what will be our observation? Magnesium ribbon is heated to make it reactive. So we heat this magnesium ribbon to make it reactive so that it can react with steam. Wet sand is heated to produce steam. So this sand here we have said it is being heated to produce steam that will react with the magnesium ribbon. The wet sand is heated first. This is to drive away the air that is initially in the apparatus that would react with the hot magnesium. So we say that we heat the wet sand first so that we can drive away air that would react with the hot magnesium. Magnesium reacts with steam to produce magnesium oxide. Remember, it is not hydroxide, it is magnesium oxide and hydrogen gas. The hydrogen gas formed is collected by over water method. We said it is slightly soluble in water, therefore it can be collected through over water method. So what will be the observation on the magnesium ribbon? So the gray ribbon of magnesium will change to white powder. So this will have the white powder will indicate that magnesium oxide has been formed. So the gray ribbon of magnesium will turn to white powder, that is magnesium oxide. So other metals that can react with steam to produce hydrogen gas are, for example, zinc and iron. So you can see the reaction here between zinc and iron, zinc and steam. So zinc metal plus steam will form also zinc oxide and hydrogen gas. Also iron also reacts with steam to form triion tetraoxide. So that is the product formed when iron reacts with steam. That is triion tetraoxide plus hydrogen gas. So that is how these metals react with steam. And those are the reaction of metals with steam. In our next slide, we have some extended question. This is KCSE question. So feel free to pause this video and attempt to answer this question. It is the reaction of magnesium and wet sand to produce hydrogen gas. The answers are in our notes. So pause the video and answer that question. That marks the end of our lesson 4. Thank you for listening. Until next time, bye bye.